In the last unit, you solved quadratic equations by factoring and completing the square. In section 5.6, you're going to use the quadratic formula to complete the square. Now, part of the quadratic formula is called the discriminant. And the reason why we're focusing on that first before we do the quadratic formula is because the discriminant can tell us what kind of solutions we're going to have and how many. So, if our discriminant is positive, then our real solutions are going to be, we're going to have two real solutions. So just a reminder, the solutions happen where the graph crosses the x-axis. So again, if the discriminant is positive, we're going to have two real solutions. If the discriminant is 0, we're going to have one real. And now I'm going to go back and just put a box around real here. If the discriminant is negative, it looks like we don't have any real solutions, which we don't, but we have what's called two non-real or complex solutions. So what we're going to do, we're just going to kind of go like this. We really have 0 real solutions, so we're going to classify them as two complex, and we're going to get to complex numbers in another section. So for right now, it's just enough to know that if it doesn't touch the x-axis, then it's complex. So going back here, it touches the x-axis in one place, so we have one distinct real solution. Okay, let's go ahead now and work with the discriminant. When you use the discriminant, this is what you use. So just like we did before when we factored, we want to put this in standard form. In front of the x squared is a, in front of the x is b, and in front of, or the constant is c. So all we're going to do basically for today is just plug numbers in and simplify. So we're going to do b squared minus 4 times a, which is 2, times c, which is 27. So 16 squared is going to be 256. And I recommend just multiplying all of these together. This is a minus, but we can think of it as a negative as well. So negative 4 times 2 times 27 is going to give us a minus 216. When we subtract those, it gives us a value of 40, which is our discriminant. Okay, now 40, when we look at 40, all we need to know, is it positive, is it negative, or is it 0? Well, 40 is a positive number, so we go back up to here. If it's positive, we have two real solutions. So the number of solutions would be 2. The type of roots would be real. Now, off to the side here, we're just going to fill in a little table. We're going to write number of solutions, and type of solutions. Okay, so if my number is positive, I'm going to have two real solutions. If my number is negative, I'm still going to have two solutions, but they're going to be complex. And again, we'll talk about more about complex in another section. If my number is 0, I'm going to have one solution, and it's going to be real. So if you look at this table, the number of solutions are either going to be 2 or 1. The type of solutions are either going to be real or complex. So it's always going to be a real number unless my discriminant is negative. You're always going to have two solutions unless my number is 0. So you basically just have two choices once you find your discriminant for the number and the type of solutions. All right, let's do another one. B squared minus 4ac. Here's your a, b is negative 1, and c is 8. So we're substituting the values in. B squared minus 4 times a times c. So negative 1 squared is just 1. And if we multiply 4 times 3, that's 12, times 8 is 96. And I've circled all these. This is a negative 96, so subtract 96. So our discriminant is negative 95. So that means my discriminant is negative, or my number is negative from my discriminant, I have 2 complex. So number of solutions would be 2, and type would be complex. All right, the third one, so here at a positive, here we had a negative. We need to make this a minus sign right here. So my A is 1. Now this is not in standard form, so we need to change this to read x squared minus 12x plus 36. If you don't put it in standard form first, your A, B, and C are going to be messed up, depending on which is out of order. So here's your A, which is 1. This is your B, and this is your C. So again, we do B squared, so negative 12 squared, minus 4 times A times C, which is 36. All right, 12 squared is 144. And multiplying all this together, negative 4 times 1 times 36 is going to be minus 144. So our discriminant value is 0. And if we go to 0, that means we have one solution, and it's in the real number system. All right, so that's the discriminant. It is part of the quadratic formula, and you probably remember the quadratic formula from Algebra 1. Here it is. And before using the quadratic formula, your quadratic equation must be in standard form. Ax squared plus bx plus c equals 0. So we want to find the zeros of the functions using the quadratic formula. We're going to rewrite this. When I sent it down for copies, the formatting changed on it a bit. So this is 2x squared minus 16x plus 27. Okay, so we want to identify the A, the B, and the C. A is going to be 2, B is going to be negative 16, and C is going to be 27. All right, so there is a negative sign in front of this B here, and you want to be really careful because a lot of times, let's look at this problem right here. If I say x equals negative b, a lot of times I'll have people just put negative 16. But you want to put the negative down in front of the b and then put the minus 16 down. And then we're going to do plus or minus the square root of b squared minus 4 times 2 times 27. All of that goes over 2 times a. So this is going to go over 2 times 2. All right, let's simplify. A negative and a negative is a positive, so 16 plus or minus the square root. 16 squared is 256. Minus 4 times 2 times 27 is going to give us 216. All of that goes over 2 times 2, which is actually, let's just simplify that now and make that a 4. All right, so now we have x equals 16 plus or minus the square root of, subtracting those, we get 40 over 2. Now, this number is too large to be underneath the square root sign, so we have to see if we can break it up into 2 numbers. One of the numbers needs to be a perfect square, or it's not going to help us to break it up. So we have 1 squared, 2 squared, 3 squared, 4 squared, 5, oops, what did we do there? 4 squared, 5 squared, 6 squared, and you can keep on going. So this is 1, this is 4, this is 9, 16, 25, 36, and so on. We want to break this up into 2 numbers. One of them has to be in our list here. So if we look down that list, we can see that we can break it up into 40 times 4. Or 40 would be 4 times 10. So we're going to rewrite this as x equals 16 plus or minus the square root of 4 times the square root of 10. That just equals 40. We just rewrote it. We didn't make it. And this is going to be over 4. That's what our denominator here is here. I just wrote the wrong number when I rewrote it. Okay, so now this changes to a 2. So we have x equals 16 plus or minus 2 times the square root of 10. All of that goes over 4. And now I am going to break up my fraction just so I can see how to reduce it. So x equals 16 over 4 plus or minus, and this is going to be 2 square roots of 10 over 4. So x equals 4 plus or minus, this can reduce, divide by 2, square root of 10 over 2. And those are your zeros. All right, let's do one more. We'll rewrite this one. Again, this is 3x squared. So 3x squared minus x plus 8. And we'll just set it equal to 0. A is 3, B is -1, and C is 8. All right, let's just fill in the values for the quadratic formula. So this is x equals, again, I'm going to put a minus here, or a negative, because that's the negative b for this, and then I write in the -1. So again, a lot of people just write down -1, so be very careful with that. -1 plus or minus the square root of -1 squared minus 4 times a times c. All of that goes over 2 times a, which is 3. Okay, so rewriting, we have x equals 1 plus or minus the square root of 1, and we'll multiply all of that together. -4 times 3 times 8 is -96. All of that goes over 2 times 3, which is 6. And then, again, rewriting it, just simplifying 1 plus or minus the square root of -95 over 6. Now, we have not dealt with square roots underneath the radical sign. So this is going to be finished in another section. So just leave it like that, and we'll just write finish there. You have a couple of questions for the U. Try it.